Good afternoon, everyone. After spending all those lovely days on trig identities, we're going to go back now to solving trigonometric equations. And at times, this is going to involve using identities to tidy things up. Okay, so, but we'll start light and move it forward from there. So here's a basic one. Solve that sine x is equal to 0.5 or 1/2. Okay, so our first step, of course, would just be to go right to sine inverse. Okay, so this is sine inverse. I'm going to write it as a fraction, 1/2. Okay, so one way you could do this is to just bring out your unit circle, okay, and look for where sine is equal to 1/2. Okay. And if you do that, you'll find that it's equal to pi over 6, okay, or 5 pi. So those are kind of our initial solutions to this equation, right? Okay, the other thing we need to add is if we're doing a general solution, so I'm just going to draw a little sketch on the side here. Okay, our first solution was at pi over 6, so that angle looks like about this. Okay, but we know, right, if you add a full rotation, okay, that'll take you back to the same spot. So that would also be a solution, right? So full rotation radians is 2 pi. So if I added 2 pi, right, to my angle, that would also be a solution. And I could do it again and again and so on. Okay, so for the general solution to this equation, we're just going to tack on a little extra piece here. So x is equal to pi over 6 plus 2 pi k, or, right, it's 5 pi over 6 plus 2 pi k, where k is an integer, right? So that expression is saying that I can add any multiple, any whole number multiple of pi, okay, positive or negative, sorry, not pi, 2 pi, to my angles, and that is also a solution to this equation. So, like, unless you're given an interval that says it's between here and here, okay, then this is the general solution to that equation. Okay. Okay, and if that picture didn't help, again, you don't have to copy this down necessarily, right? But as another little visual of why that's true, right, is if we were to graph sine quickly here, right, it looks something like this. Okay, so if my initial solution was here at pi over 6, then if I go 2 pi, I have another solution here. And if I go another 2 pi, I have another solution here, right? That's what this part is saying right there, is I can keep adding multiples of 2 pi. And that gives me more solutions to this equation. The next one. Okay, we're going to solve cos squared x minus 1 is equal to 0. Okay, there's at least 3 different ways to solve this. But just for practice, I'm going to go with the whole, let's recognize this is a quadratic thing, right? I have something squared and something squared. So this is a difference of squares. Okay, it's quadratic. So I could factor this as cos x minus 1 times cos of x plus 1 is equal to 0. Okay, so that means that either cosine of x is equal to 1, right? Or cosine of x is equal to negative 1. Okay, so we'll solve each of those separately, right? So x is equal to the cosine inverse of 1. And again, if we check our unit circle, we're going to get that is equal to, not pi over 2, pardon me, that's equal to 0. Okay, and then for negative 1, if I do my cosine inverse, again, we have a look at our unit circle. Okay, we get x is equal to pi. my general solution then is that x is equal to 0 plus 2 pi k, or we could have just written 2 pi k, or it's pi plus 2 pi k. Okay, where k is an integer. Okay, and then my full solution, or such as a general solution to that equation. Okay, next one. Solve that root 2 sine 2x is equal to 1. All right, so first thing we're going to do is isolate sine of x. So sine 2x equals 1 over root 2. Okay. Because I only have the one expression, sine 2x, I'm not going to use the identity here to break it apart. I'm just going to keep isolating, to go towards isolating x. So I have 2x equals sine inverse of 1 over root 2. Okay, so we're going to go to our unit circle now, right? Once again, look up what our possible values are. And I'm just going to shift my equation over a bit here because I need a little bit more space to center it. Okay, so when I look up on the unit circle, okay, 1 over root 2 for sine occurs at pi over 4. Okay, and again, we'll go right to the general solution this time. So plus 2 pi k. Okay, and it can also be at 3 pi over 4 plus 2 pi k. Okay, and that's where k is an integer. My final step is going to be to isolate x. So I'm going to have to divide all of the things by 2. Okay, right? Everything over here is going to get divided by 2. So pi over 4 divided by 2. So half of pi over 4 is pi over 8. Okay, 2 pi k divided by 2 would be just pi k. Right? 3 pi over 4 divided by 2 is 3 pi over 8. And 2 pi k divided by 2 is pi k. And k is still an element of the integers. Okay, so there's our full solution to that equation. Okay, example 4, similar idea, except I've got a 3x now, and I have a specific interval. So I only want the solutions that lie between pi and negative pi. We'll start this off the same way. So 3x is equal to the sine inverse of 1/2. Okay, so again, a little unit circle. Okay, and look that up. So our possible angles here, actually I think we did this at the start, didn't we? Pi over 6 plus 2 pi k, and 5 pi over 6 plus 2 pi k. Okay, our next step after that will be to divide everything by 3. So we have x equals, okay, pi over 6 divided by 3 is pi over 18. Okay, plus 2/3 pi k. And then we have 5 pi over 18 plus 2/3 pi k. Okay, that is our general solution. Okay, now we need to start looking for the specific solutions, okay? Because we said we wanted this to be between negative pi and pi. Okay, so I'll show you the idea. Okay, I'm not going to go through every single piece here because it'll take a while. But let's start with the first one. Okay, I had pi over 18 plus 2/3 pi k. So let's see what happens when k is equal to 1. So pi over 18 plus, okay, I'm going to just rewrite this as 2 pi over 3, right, times 1. Okay, so really I need to figure out what's pi over 18 plus 2 pi over 3. So I'll get my common denominator. That would be 18. So I'll multiply that by 6. So that would be 13 pi over 18. Okay, is that still less than pi? Yes. Okay, right. The fraction 13 over 18 is less than 1, so we're good. Okay. So let's try to get the next one. Okay. If I did pi over 18 plus 2/3 pi times 2, okay, well, that would be 4 pi over 3. So I'd have pi over 18 plus 24 pi over 18, which is 25 pi over 18, but that's too big, right? 25 over 18 is above 1. Okay, so that's no good. So we'd stop moving in that direction. Okay, but I can now go in the other direction. Okay, so I go back to my equation again. Let's try going the other way. No, that's not going to work. So pi over 18 plus 2/3 pi times -1. Okay, right, because k can be any integer, so I can also go in the negative direction. So that means I would have pi over 18 minus 2 pi over 3, which we found out earlier was 12 pi over 18. So -11 pi over 8. Okay, that is bigger than -pi because my fraction is less than 1. So this one is okay. Okay, and if we kept this going, right, if we went to -2, I'd add another 12 pi over 18. I'd have -23. It would be too big. So from my original pi over 18 angle, okay, I have added to my list, I have pi over 18, right, 13 pi over 18, and -11 pi over 18. Those are 3 angles in that interval that work. Okay, so we would now have to do the same thing with our other angle. Right? We also found that 5 pi over 18 was a solution, so I'd have to do this testing with 5 pi over 18 as well and see what I get. Okay, so again, I'm not going to go through that because I think you get the idea how that works. Okay, but from 5 pi over 18, okay, we also get 17 pi over 18 if we move forward. Okay, and we get -7 pi over 18 if we move backward, and that's the extent of the angles. Okay, so our final solution, these are the 6 angles between -pi and pi that satisfy that equation. All right, on to the next one. And I know there's a lot of stuff here. Okay, example 5. Solve for x. Secant 2x plus 1 over cos x is equal to 0. Okay, so here's an example of one where identities are going to come into play. Okay, so identities, the first goal would be to try to get all the same ratio if possible. Okay, so we're going to note that the secant is the same as 1 over cosine. So we'll start there. The equation is now 1 over cosine 2x plus 1 over cosine x is equal to 0. Okay, I would like to clear out those fractions. Okay, so I can multiply, we'll start with the cos 2x. Well, I'll draw it down the side here. Basically, to clear out those fractions, right, we're going to multiply everything in this equation by cos 2x, cos x. Okay, on the right-hand side, it's times 0, so that's not going to really do anything. So when I multiply that through, right, my first fraction, okay, I'll do it the long way. Okay, I add cos 2x. Yeah. Pardon me, I'm going to write this on the long form just so it's clear what I'm doing here. Okay, so I'm multiplying every term by cos 2x, cos x, right, times 1 over cos 2x plus cos 2x, cos x, times 1 over cos x equals 0 times those two brackets. Okay. Okay, when I tidy that up, these are going to cancel. So I get left with cos of x plus cosine of 2x equals 0. Okay, our next step. One of these is cos x and one of them is cos 2x, so I can't really combine them, right? I can't say this is like 2 cos 3x. That's definitely not allowed. Okay, so now I turn to my identities. Okay, I would like to replace cosine of 2x, okay, with something that's useful to keep solving this equation. Okay, and we know there's three versions of this, right? There's cos squared x minus sine squared x, there's 2 cos squared x minus 1, and there's 1 minus 2 sine squared x. So because I am basically working in terms of cosine here, let's use the version that only involves cosine. So for cos x, okay, I'm going to replace this equation with 2 cos squared x minus 1, and that's equal to 0. Okay, I'm just going to rearrange this a tiny bit. Okay, but basically, this kind of looks like a quadratic. Right? 2 cos squared x plus cos of x minus 1. Okay, and if it helps you to see that, we'll do a little substitution here. So let y equal cos, not cos squared, cos x. Right, so it looks something like 2y squared plus y minus 1 equals 0. Okay, so we're going to need to factor that. Okay, right, this is the whole multiplies to -1, sorry, -2, because it starts with a 2, adds to 1. So my numbers are -2. Nope, they're +2 and -1. So we split the middle. 2y squared plus 2y minus 1 equals 0. So we have 2y, y plus 1, minus 1, y plus 1. So this factors into 2y minus 1 and y plus 1 equals 0. So that means y is equal to either 1/2 or -1. All right, now we switch that back to cosine. So that means that either cosine of x is equal to 1/2 or cosine of x is equal to -1. Now, going back to the top for a brief second, okay, our restriction was between 0 and pi for this, okay, for our solutions. So basically, I just need to look at the top half of the unit circle and see where my answers would be. Okay, so when we look at 1/2, okay, the only place between 0 and pi where cosine equals 1/2 is pi over 3. And for -1, we did that one earlier, x would be equal to pi. So our two solutions to this equation, which is really quadratic and cos, is that x equals pi over 3 and pi. And we're good. Okay. So yeah, if you have a situation where you have two expressions that don't necessarily work very well, right? We couldn't really combine cos x and cos 2x right away. Okay, you may have to use identities to make replacements and then solve the equation, right? The goal would be just to get them all in terms of one ratio, if possible. Okay, which leads us to our final one. All right, cos x plus sine x equals 0. Okay, and I'm just bringing this one up because it's a special case. And well, I never want to call it a trick. Okay, but it's something you should see just to show how to solve it, because it's not an obvious thing. Okay, because we don't have any identities that directly bring cos to sine or sine to cos. Right? You can do that with squares, but there isn't one that's nice. So let's just do that. Okay. Like there are some other identities, like, you could change, say, cosine to sine of pi over 2 minus x, but then they don't have the same expression, right? And that makes it worse again. So how we're going to solve this one is I'm going to bring cosine to the other side of the equation. So sine x is equal to negative cosine of x. Okay, I'm now going to divide both sides by cosine. So sine x over cos x equals -1. Okay, so yeah, this workaround will allow me to change my ratio, because sine over cos is equal to tan. So tan x equals -1, and now I just have to do the tan inverse of -1. Okay, again, our restriction was between 0 and 2 pi, so I've only got to look at the unit circle, and I don't have to do any other angles than that. Okay. So that means that x is equal to 3 pi over 4 and 7 pi over 4 from the unit circle. Okay, and we're done. So I know there's a lot, okay, but that's going through the trig equation solving skills. Okay. So for practice, okay, I feel like I should cut it down a little bit. Like, don't feel you have to do all of these, okay, but there's the practice list that I have on my notes from before. Okay, right. And you probably want to focus on these ones. Okay, like the early ones are probably really straightforward. Those are a little bit more challenging. Okay, but yeah, for solving equations, there's the practice for that. Okay, or of course, if you want to work on your assignment a bit, you can do that. One quick note about the assignment. Okay, and it was pointed out to me yesterday that on question 2, right, so this one right here, okay, it says solve for x, but it's not an equation. It doesn't say equals something. Okay, so that equation should just be equal to 0. All right, I can't really write on it right here with the way this is set up, but yeah, this should be equal to 0. Okay, but yeah, you have the tools to work with this now. You can see it's got a cube and a squared, so you're going to have to do some factoring there to solve that one. Okay, so again, either practice on this, work on your assignment. Okay, thanks for watching, and I will see you tomorrow.